These are potassium spheres. If I throw them into a bucket of water, well, you know what happens. I produce them starting from bananas. The first step is simple. Peel the banana and eat the fruit, because what we actually need is the peel. It's important to let the peels dry for a few weeks until they are completely dehydrated. We should collect a very large amount of them, filling an entire pan if possible. This process takes months, but the drying time is essential so that later we can burn the peels easily. Pour some alcohol over the dry material and ignite it with a torch. As the material burns, you'll notice a whitish residue forming. These are the ashes, composed mainly of metal oxides. In the case of banana peels, we have a very high concentration of potassium and very little organic matter left. Knowing this, we can now add water and filter the mixture. Magnesium and aluminum oxides turn into insoluble hydroxides, so they remain in the filter. What we obtain is a solution rich in potassium hydroxide and potassium carbonate. Check the pH. You'll see it is close to 14. Now let's bubble carbon dioxide through the solution to convert all the hydroxide into carbonate. I do this until the pH drops to around 11. The color you see comes from iron impurities. Then I add activated charcoal and let the solution warm up to reduce its volume. The next day, I filter it again, and we obtain a much cleaner solution. Now we simply need to remove all the water. I transfer the liquid into a wider container and let it dry until it becomes a very fine powder. Look at the amount of potassium carbonate we get. It still contains some impurities, but that won't be a problem for the next step. In this method, the potassium will literally turn into vapor. We are going to distill the metal and collect it at a different point. For that, heating alone isn't enough. We need to add metallic magnesium. I mix the two reagents and place them inside a steel container with an outlet at the top. Although potassium is more reactive than magnesium, heating the carbonate in the presence of magnesium produces a large release of energy. This is due to the formation of magnesium oxide, which drives the reaction forward. So magnesium acts as the reducing agent. It donates electrons to potassium, reducing it to the metallic state. Metallic potassium becomes volatile at high temperatures. It vaporizes and condenses elsewhere in the system. With that in mind, I fire up the forge to maximum. Within minutes, we can already see potassium dripping into a pan filled with mineral oil. In the end, I was happy to find a large amount of it in the pot, although part of it formed tiny droplets. I gather everything I can into a beaker so I can melt these small pieces together into larger drops. I place them on a heating plate. The oil must be changed several times to remove as many impurities as possible. I repeat this process until I obtain the clean, shiny spheres shown at the start of the video. When you cut one open, you can clearly see its metallic sheen. Hard to believe this came from banana peels. It almost looks like magic. But it's just chemistry.